All right, we're looking today at geometric sequences or algebraic sequences or arithmetic sequences, whatever you want to call it. And if you're looking at it and you say, hey, this formula looks vaguely familiar to stuff that we've been doing, you would be correct. Just give you a quick translation that we have y equals a times b to the x power. That's our exponential function. And this is a to an is a1 times r to the n minus 1 power. So basically the x is turned into an n minus 1, b turns to an r, and the y turns to an an. So plenty of commonalities here, or similar things that are going on. It's just a little bit different way of looking at it to be able to show things as a sequence, which really gives you a way of listing out numbers as they go along. And really, when you get into coding and generating lists and things like that, this type of formula becomes kind of key because you are able to, with the n minus 1, get a sequence that continues on and on and on just by typing in the equation versus having to graph a function. This also just gives you individual points and not a full graph. So there are a few differences, but the basic formula we have is still going to look the same. So the sequence is a list of numbers where the next term is found by multiplying the same factor to each term. And so what you're multiplying by would be the common ratio. Ratio being the R value. That's a constant factor between the terms of geometric sequence. And so it wants us to just figure out what's the common ratio. What are we multiplying by? Which is really just how we found b, the b value, when we were looking at tables on our exponential functions. So what is being multiplied by as we go to each one? So really we can just think 3 times what is negative 9? We'd say, well, times negative 3. And the same for negative 9 to 27, multiplying by negative 3. So that would be our common ratio. So we just say R is negative 3. Looking at the next one, 20, 40, 80, 160. As we go along here, hopefully we say, oh, well, they're just multiplying by 2. So R is 2. And as we look at the next one, if they're getting smaller and smaller, I would say, well, it looks like I'm dividing by 4. And so since I'm dividing by 4, I'm going to turn that into multiplying by 1/4 because that actually means the same thing. So my R value is 1/4. Okay, so a little bit about the formula, diving a little deeper into it. AN is going to be our output. Or if we wanted to know the 10th term in the sequence, we would put a 10 in for n if we had our A1 and our R value, and we'd get what it was. So the nth term. So if it says, what's the 7th term for this, you'd put a 7 in for n. We do that. A1 is the first term. R, of course, we said is the ratio. And then n would be our input, just like our x. So input, or the term number of the sequence. So using the formula, right, equation that can be used to find the nth term of the first sequence above. So looking at this, we already know the R value is -3. The first term in the sequence is 3. So A1 is 3. And so those are really the only two numbers I have to have. So A to the n, or AN, equals 3 times -3 to the n minus 1 power. And so the way it works is if I want the third term, I'd say in 3, and so I do 3 minus 1, which is 2. So -3 squared would be 9, and 9 times 3 gives me 27. So it really does work in a way that helps you find everything you need for that. So you're also going to have these where it says, what are the first 4 terms in the sequence? And so my first term is always going to be that A1 value. So that one's 3, for instance. That one's 2. That one's 5. Then I'm just going to multiply by 4 each time. So 3 times 4 is 12. 12 times 4, 48. And then we get up to 48 times 4. Could work that out, but it's 192. So again, just multiplying by 4 each time, because each time I raise that power up, it's multiplying by another 4. Here we do the same thing, just with 1/2. Let's say half of 2 is 1. Half of 1 is 1/2. Half of a half is a fourth. And for the last one, I'm multiplying by -5. So it would be -25, and 125, and then -625. And the other way you could see it is writing the nth term of the geometric sequence, or an equation for it. So if we write the equation, it'd be A to the n power equals, always our first term to start. And I could say, well, looks like I'm dividing by 3 each time. So that means I'm multiplying by 1/3. And instead of an x up front, or up top, we'll put n minus 1. And so that's a formula to tell me what happens each time. So same thing, A of n equals 2. And 2 times 8 is 16. So I'm multiplying by 8. So 8 to the n minus 1 power. And here, if I get to where, okay, I'm not sure what that is. I know at least A to the n power is 15 times, and we can do 9 divided by 15 to get what that number is there. So I'd simplify it to 3/5, which is just equal to 0.6. So if we divided it, I would get 0.6, or we could just write 3/5 to the n minus 1. But that's just taking those first two and dividing or simplifying it in order to get that number. Similar to what we've done to get the b value in our exponential equation. So that gives you a good idea of how to work these. You got a couple you can practice on there along with your assignment.